Hazards of electricity. Now, I'm showing some famous hazards, and these are in our common life. Electricity is all around us, and many times we come across problems with electricity like damaged insulation, overheating of cables, damp conditions, excess current, surge effect, short circuit, leakage of current in a metal casing, which causes electrocution. You have to now copy this screen. These are some common hazards of electricity. Some of them have to be done in detail. Damaged insulation, overheating of cable, like overheating. This is called overheating. You must have seen these type of plugs and sockets which turn dark black because of overheating. Damaged insulation. The insulation gets worn out. Overloading. What is overloading? Overloading means you connect lot of things in one socket, which normally we do, which is a serious mistake. And in Pakistan, we do these things. In a one extension, we have connected many things. This is called overloading. This is called overloading. Overloading is a common problem where people do not take care much of taking in account of the current and the voltage. So this is called overloading. This is called overloading. And overloading is a case when you have connected a lot of devices in one socket board. Look at this screen. Look at this short animation, and you people can guess. My question is there. Even though the guy is looking very happy, but he is doing a serious mistake. Can you tell me what mistake he is doing? Yes, very good answer. The guy is overloading. This is the problem associated with overheating, overloading, the burn down of the plugs. Extensions, old ones, can catch fire due to overloading. This is a very common hazard of electricity. Surge effect. We discussed it once before also, so I'm not going to discuss it again. Actually, surge effect, what is surge effect? It is the sudden increase in current or voltage and it causes overheating. Damp conditions are very, very dangerous feature. If you are working on electricity and your feet are wet, then it's a very big danger. Or if your hands are wet and you are using electricity, so these are the common hazards. Now, give the new heading, live, neutral, and earth. These are the three main wires in a circuit. Copy this. These are the three wires, live, neutral, and earth. The colors are not required in our course, but the concept is needed. We first put the concept live. Live wire is the main wire and it has maximum current, maximum PD. High energy electrons are transferred through the live wire. Live wire is the main wire. It is the source of energy in a circuit. You have to copy this. Hmm. This is live wire. Live wire carries high energy electrons. That is why circuit breaker, fuses, all safety components are connected in live wire. Now comes neutral wire. It is the return wire. It is the return wire and it has zero potential difference and maximum current. It is the return wire. So you have to copy this screen. Copy this. When electrons transfer energy to the device, they return to the socket via neutral wire. So this is how electricity works. Live wire carries the electrons to the device. They give them energy. Then they come back from the neutral wire. So neutral wire is the return wire. You have to make this circuit. Let me know once you have copied it. Now we come to earth wire. It is a safety wire. It is not always needed. It is needed when a device has a metal casing like iron, outer unit of an air conditioner, older type of printers which contain metal casing, washing machine, older washing machines, now they are in plastic body. So they used to have this case, and this is called earth wire. It is the third pin in our 3-pin plugs. You have to copy this. Earth wire has a 0 volt and 0 ampere. Earth wire is like a drain. Earth wire is like a drain wire. Earth wire is used. Earth wire is used as a safety precaution. Normally, earth wire is not active. It is like a emergency exit in a building, which is normally not active. And may God not, if there is a fire breakout, the earth wire will try to protect the object. It is needed when the device has a 3-pin plug. Normally, devices do not need 3-pin plug until they have a metal casing. When they have a metal casing, then they use it. Just a minute, please. I'm just connecting back. We are discussing the concept of earth wire, and normally, as I mentioned, normally earth wire is not needed until the device has a metal casing. Until the device has a metal casing. When the device has a metal casing, then there is a chance. Then there is a chance that the metal casing can be live by the metal casing can become live due to the connection. So this is a 3-pin plug. This is a 3-pin plug. The thicker wire is the earth wire. One of them will be live wire and second one of them is the neutral wire. Now, earth wire is a thicker wire and it is a safety wire. It is for the safety. Now, give a new heading, safety measures against electrical hazards. Give a new heading. Number one, fuse, trip switch, and circuit breaker, double insulation, dry condition, earthing, plastic casing, and correct rating. These are some of the important safety measures. Trip switch is a new topic and they have introduced it last year. Earthing is a very important topic. It has appeared many times in our exam. So these two topics need special attention. Uh, Trip switch is a new topic and earthing is not a new topic, but it's very important. It comes very oftenly. You have to copy this screen. You have to copy this screen, safety measures, and let me know once you have copied it. This is the list of important safety measures. Now, I'm starting with fuse. Fuse is a very common thing in vehicles still now, but in our houses, but in our homes, fuse is now a bit less common. It was a very famous thing in our houses, but not now. Many electrical circuits now contain fuses, circuit breakers, but fuse is getting a bit rare. Fuse is a safety measure against fuse is a safety measure against excess current. Fuse is a measure against excess current. So fuse protect us from high current. So fuse is a safety component against excess current. You have to copy this, the symbol also. Fuse is a safety against excess current. Look at this diagram. This is called a fuse. Now, how fuse works? Fuse is a thin wire. When large current passes through the wire becomes hot and it melts. Temperature increases until the temperature reaches the melting point, until the temperature reaches the melting point of the wire, and the wire melts. And the wire melts. It's a melting of the wire which breaks the circuit. When the wire melt and break, the circuit stops. This is a thin wire like a filament. When large current flows, the wire melts and stop the current. This is how fuse works. You have to copy this. This is the appearance of the fuse. This is the appearance of the fuse. Different fuses are in different sizes. A fuse melt and break. This is offered to and blowing up. So normally when we use a fuse, we generally put at least 1 ampere above the current in the wire. So when it's a 3 ampere current, when it is 3 ampere current in the line, you should use at least 4 ampere above the wire. So for example, 2.1 ampere, for example, the current is 2.1. So you should use 4 ampere fuse. When it is 3.9, you should use 5 ampere. So fuse is always rated above the line current so that it can stop the excess current. Now you have to copy this screen. Hmm, hmm, hmm. So this is a concept of fuse rating. Whenever you are willing to use a fuse, you have to look for the correct rating. Otherwise, the fuse can't provide the safety. Look at the diagram. I'm attaching devices in parallel and the fuse blow up. Look at the animation carefully. The fuse has now blown up. Why? Because in parallel, resistance decreases and current increases. Look at this screen again. I'm increasing the devices in parallel, so the current will increase. Hmm. In every conventional circuit, fuses are used. To look at this circuit, we have used a fuse with every device. These are heaters, indicator lamps are there. And there is a big fuse in the circuit, which is called the main fuse. Fuse is available with every device as an individual protection, and there is a big fuse in the main circuit. Now we put our next concept. A fuse is always connected in series in the live wire because it's a guard, it's a protection. It has to be in the line. Switch should also be in live wire. These are important concepts to remember, that everything which is important should be in the live wire. You have to copy this screen. Fuse is generally enclosed in a plastic casing, and the problem is there. Once a fuse has blown up, it has to be replaced. That's a major problem with a fuse. So you can't repair it, you can't reset it. Once a fuse has blown up, it has to be replaced. You have to copy this screen. A fuse, once blown up, has to be replaced. Now I'm starting trip switches. This is a new topic, and we got it, trip switches, this year, 2023. Trip switches are basically fuses, and but they have a switch style. So you can control their position, you can control their position, you can reset them. So they appear like this. These are the trip switches. Look at the screen. These are called trip switches. They are like a breaker, they are like a fuse. So trip switches, when the current is passing through the switch, for example, if the rating is 13 ampere, it trips, and the circuit is broken. You can reset it by moving the switch down or up according to the setting, and you can restart the circuit. They are resettable fuses. So I have to give the heading and copy this. They are resettable switches. This is the appearance of these switches. They are called resettable switches. So trip switches are actually resettable fuses. You have to copy this. Now, this is a very important concept to remember. Fuse, circuit breakers, switches, they all are in the live wire. Why they're in the live wire? Because live wire provides us safety, and it's a safety line is needed there. Live wire is actually the main wire. So every type of safety is needed in the live wire. So whatever you want to protect, it should be in the live wire. We are now starting earthing. It is a safety technique used against the current leaking in a metal casing. If current get into the metal casing, it's a very, very dangerous situation because it can cause severe problem. Current is a silent danger. It can make a big problem, but it has no visible issue. Current is not visible, and it can create a severe loss for the user. So you have to copy this. Earthing comes in two positions in our course. One is called electrostatics. When it comes there, it's for insulator. Second, it's here for electric circuits for safety purpose. We have to copy this. Copy this and let me know once you have copied it. When a 3-pin plug is used, the thicker pin is for earthing. This is a 3-pin we already discussed. Normally, remember that when we have a 3-pin plug, the third pin is always for earthing. So copy this also. How this circuit works, remember the issue is there when there is a metal casing. When there is a metal casing, this is the live wire, this is the neutral wire. Now, what happens when we want to connect it? This is the earth wire. Now, remember, earth wire is a safety wire. Whenever we are talking about earth wire, it is a safety against excess current, leaking current. Earth wire is a safety against the current leaking in the metal casing. So when you design a circuit for safety, you attach a thick wire, which is the earth wire. It is going physically to the earth. So we have a live wire, we have a neutral wire, and we have a earth wire. So you have to copy this. Let me know once you have copied it. Okay, so we keep it up to here. Maha, have you copied it? Okay, so we keep it up to here and we will inshallah continue in our next class.